Hello everyone, this is Deepak Joshi, and today we are going to solve another problem statement from LeetCode. This question is very similar to the last two questions that we have solved for graphs. Okay, not graphs, binary trees. Okay, so, let me remind you what last questions that we have did. It is not related to that, but if you have watched those two videos, then it will make more sense to solve this particular problem. But you will be able to without watching that video as well. But I'll make sure to remind you that, uh, like in those last two questions, what we did is we were trying to put a binary tree into a y-axis line, converting that into 1D. What it helped us to figure out like what are the nodes that are lying on the same x-axis, not y-axis. Okay, same x-axis. Let's just go through the problem statement of this particular problem, and then let's try to relate a lot of things over here. So this is marked as a hard one in on lead code, vertical order traversal of a binary tree. We will be given a root of the tree, and what they have mentioned is the coordinate of the root will be 0 comma 0, and the coordinate of the left node or the left child of the current node or the root will be row plus one. Means row has been added but column minus one, that means it is shifted to left side. And for the right child it will be called row plus one but column plus one as well. Okay, so for left we will be doing column minus one, and for right we will be doing column plus one, and in both the cases we will be adding one to the rows, like row plus one. Okay, that makes sense. Now they are mentioning that we need to find out vertical order traversal. Let's figure out what is vertical order traversal. The vertical order traversal of a binary tree is a list of top to bottom ordering for each column index, starting from the leftmost column and ending through the rightmost column. There may be multiple nodes in the same row and same column. In such a case, sort these nodes by their values. That makes sense. Like what is vertical order traversal is, we need to start iterating from the leftmost child. We need to iterate all the nodes and go towards the right, but we need to make sure one thing, that if any of the node lies on same y-axis coordinate, then we should sort them out. What do I mean? Let's take this example: 9, 3, 15, 20, and 7. Okay, so if I yeah, that's fine. If I consider the coordinate of root, that is 0 comma 0, and the left of it is 1 comma minus 1, which is fine because we will add 1 to the row and minus 1 for the left child in the column. Okay, now vertical order traversal means states that start from the left. Okay, that means my vertical, I'm just writing vertical order traversal over here. Vertical order traversal, that will be 9. Now on zeroth column you can check like the coordinate for this particular 3. Is it? Yeah, yeah, here we can look at it closely. The coordinate of 3 over here is 0 comma 0, x is 0 and y is also 0. But for 15, how 50, but for 15 the coordinate is x is 2 and y is 0. How let's confirm. It is 0 comma 0. The rightmost child of it, the right child of it will be 0 plus 1 and 0 plus 1, because we will be adding 1 to row and column both. That's why 20 is 1 comma 1. But for 20 the left child will be add 1 to the row but subtract 1 from the column, that is 2 comma 0. That means the column here are same for 3 and 50. And if I read the definition of vertical order traversal, is a list of top to bottom ordering for each column index starting from the leftmost. So we need to consider this 3 and 15 both, but we should consider them in a manner that they are sorted. That makes sense. Okay. That means I will be considering 9. I will be considering 3 first and then 15. Okay. Then 1 comma 1, that is 20. Then 7. That should be my vertical order traversal. Let's see. 9, 3 comma 15, 20, and 7. So what they have did is they have paired, because our return type is vector of int. That means we need to Okay, return the vertical order traversal. That makes sense because for each column we are returning an array. So for 9, it's a separate single column. That's why it's an array. And for the zeroth column, it's the this group. And for first column, it is this group. And for second column, it is this group. Okay, 9 is on the minus oneth column. That makes complete sense over here. Okay. Now, how we will implement this particular problem statement? That is completely easy, but we need to add a lot of some basic things to our previous approach. What we can do here is we can iterate over this binary tree. How we will plan to iterate over this binary tree? Simple, BFS. You can do DFS as well. That completely depends on you. Okay, I'm choosing BFS over here because we have seen previous two problem statement that we are much comfortable with BFS, and there is another reason why I'm considering BFS over here. Like no special reason to consider BFS or DFS. It completely depends. You can choose any because yeah, that no special preference over here why I'm choosing BFS. Okay. Yeah. If there is any, please feel free to comment out, and I'll just understand. Okay. That makes sense. Now, how we are planning to do this thing is we need a queue. Okay. That will store the index and the node itself. Okay. We will be storing uh, the not the index in the queue because we need to store the node. That is the first thing, and we need to store this row and column as well. Okay, these are the indexes. There is no single index this time. There are two indexes that we need to take care of. So how we will do that is we need to store tree node. Okay, let me zoom a little bit, and we need to store a pair that will be int comma int. This is my queue. So I'm storing node and the x and y coordinates over here. That makes sense. So we have stored like queue over here. Now we need a map as well. So what this map will store, this map first will store the row. So row will be in int, and we need to take care of the column because we need to sort it out in the on the basis of column. We can have the column over here, but what I need to do is we need to refer this column with the arrays that we are planning to store. Okay, all right, like this 9 comes with -1. This is the column number. X has been stored in this particular int. I need to store -1 and 9, or 0, the yth column, that is 0, and then 3 and 15 linked to them. That can be done easily with this another map inside it, and you can do vector of int over here, and let us name it as map. Okay, so what I'm storing x and y that is linked to nodes data. That if that is making any sense to you. Okay. Okay, that is great. But there is one thing that we need to consider over here is that it mentions that binary tree is a list of top to bottom ordering for each column index starting from the leftmost column and all la la la. There are there may be multiple nodes in the same row and same column. In such case, sort these nodes. We need to sort it out as well. So like storing map is also fine. What we can do is we can store map, and then when we will be storing this particular vector inside a final answer that will be vector of int. We can sort that out over there, or what we can do is we can use a multiset over here. No need to uh like no need to take care of sorting and all. What we can do is just this, simply store a multiset. I think I need another bracket. I guess I am good. Let me just confirm whether my brackets are making sense here. So this has been closed. This particular one is okay. That is making complete sense. Oh, what is this? I think there is something that I did wrong. Uh, yeah, now it is fine. Yeah. So that is what I need to have. And do I need to have anything else? No, I don't think so. It's just push things into my query, not query, my queue. That will be my root. And I will be starting with 0 comma 0 because the starting is 0 comma 0 for 3 as well. Okay. Now what we will be doing is we will just go and check, iterate over the all the nodes until the queue is empty. We'll just get the initial or the front thing that is there in the queue. That will be q dot, not q dot, but yeah, q dot front. And the first thing is going to be node in that. Okay, so I'll be getting the node. So that will be tree node front. I can get it using it dot first. My first spelling is color. Yes, that makes sense. Now I need to get the x. That x will be it dot second dot first. Why Deepak? Because this is my it, that is referring to q dot front. That like second will be this pair, and I need to get the x. The x will be stored here. So I'm getting it dot second dot first. And if I need to get the y, that will be it dot second dot second. That makes sense. I have got the um, queues front. I can pop it up as well so that repetition does not happen and it does not go in an infinite loop. That is completely fine. Now what we need to do is we need to map this x and y to this particular map that we have. Okay, so we have this map x, uh, y, and what we will do is we will up not because we have on y, like I'm here multiset, I'm like this is the x. For this y I have my value as multiset. So in multiset what we can do is we can easily insert things out. Okay, so that insertion can happen here, and that insertion will be nodes value or friends data. That's it, because we are storing nodes data over here. That makes since I think that is not data, that is value. Yeah. So will, okay, that is right. I am on int I x and then this y. Now this y contains the value is multiset, and on in this multiset I'm storing fronts value. Now what I need to do is I just need to check whether fronts left exist. If it exists, I need to push front left, comma. For left, what we need to do is the x-axis will increase, but the y-axis will decrease. That is absolutely right. And for if fronts right exist, what I need to do is I need to push q dot push front right and x plus 1 and y plus 1. That makes sense here as well. Okay, so this is one thing that we have did. Now what will happen is our map over here will contain the relationship. Like it will contain first the x-axis part, like for 0, not 0, for yeah, for 0 1 1 2, the x-axis comparison. And for y-axis it will contain a multi-set. So we need to get that multi-set out because that multi-set is already sorted. What we just need to do is we need to iterate over that. So for auto p of map, what I can, oh, I need a final answer over here to return as well. So what I can do is I can create a vector of vector int, because that is what we need as an answer. And for now, because we will be storing the column, I'm just writing a temporary column over here. And so I have this p will refer to this map. Okay, I'm just try to understand what I'm doing here. I am iterating over this map. That means like this is my complete map. Okay. Now I am on auto p. Okay. That means I am on this particular part. I have got this int, and now the value will be pointing out to this. If I'll do p dot first, that will be over here. If I'll do p dot second, that will be here, right? So I have created a temporary column column vector over here, and what I'll do is I'll iterate over the let's name it as q, and I'll iterate over p dot second, if that makes sense to you. If that is making sense to you, like initially I was iterating over this whole map. All right, and then this particular p is my this value. Okay, now if I'll point out this p at p is my key. Okay, this particular int, and the value for that is this particular map. If I'll do p dot first, it will point me to y-axis. Okay, And if I'll do p dot second, it will point me to all the element present on the y-axis, all the nodes value present on that y-axis, right? So what I'll do is I'll store everything. Yeah, I was doing right. I'll store everything. How where to push, like, because I haven't specified the position, like how we do it. Like I haven't specified. Oh, we can do one thing. We can do insert as well. Okay, just instead of doing pushback, because then we have to do not this and iterate over it, so we can do insert. We have to push column dot end is the position where I need to push, and what I need to do is I need to start with call q dot. So it is q is pointing to this particular thing, and I just need to get the so sorry, this, yeah, I just need map over this, and I just need to get this particular multi-set. So that will be q dot second, because right now my p dot second is this particular map. Yeah, that makes sense. So that will be q dot second. What I need to do is, for example, let's say my map contains 1 comma 1 2 3. So I need that my column should contain 1 comma 2 comma 3 as it is. I don't want to iterate over it, because my multiset is already sorted right now. So I will do q dot second dot begin, put everything in once, q dot second dot end. This is my tactic to insert everything from beginning to end. And we will, once we will have our column, just insert it into answer and return from here. Let's go through it once more. I initialized a queue that will contain the node. I'm just checking. Oh, yeah. So I have initialized a tree node. All right. Add a pair that will contain x and y. That is fine, Deepak. And then I have a map with key as x-axis, and there is a value that is again a map containing y-axis as a y-axis as a key, and the multiset. Multiset will contain the nodes present in the nodes present. Yeah, the nodes present in the graph, okay, related to on that particular y-axis. That is fine, that is completely fine. Now what, like, this is for the final answer. I inserted the root node into the queue with 0 comma 0 as an index, and then I started a while loop until the queue is empty. I got the front node, like the same thing, the node and the x-axis y-axis, inserted the formed the map, and then extracted the data out of the map. Let's try to run this out and see if it works. It says uh, something is wrong, and I don't know what is wrong. It says value type node in instantiation of template class requested here. Error, no type named value type in pair in comment. Okay, so I haven't declared the value type over here. Oh, ah, I have done a mistake. Actually, this queue is only of single type. Like it will have only single thing. So I need to wrap it up inside a pair. Now I guess it will work fine. Yeah. Let's run it again and see if there is another error. Oh, it says yeah, like what is happening? 3 9 20 15 7. I guess there's some link issues. I have done something wrong. Let's see what's wrong. 3 9 output is 3 9 20 15 7, and ideally it should be 9. And ideally, yeah, it should be 9, because but it is starting with the root node and then 9 on the left side and going on 20 for me, and then on 15 and 17. Very wrong. Yeah, so like the thing that we were missing actually was that the left child is basically on the left side, like for the x-axis to be passed in. Like I was just mm, messing with it. Like how can I make sure that my graph relation with the y-axis or with the x-axis is right? and I found that I'm making a mistake over here. Like the left child will be on x minus 1, and on column it is same, because the relationship that we have defined, that this x will contain y key and the multiset in sorted order. These values are in sorted order. So that is what I was missing. I guess now it will work fine. I guess there is an issue over here as well. No, no, that's fine, because on the right side x plus 1 will work, and and the column value will increase. Like the column value for the lower node, lower levels will increase. That is what, yeah, it has been submitted. I guess I was able to resolve the issues, and I was able to explain the code as well. Thanks for watching. See you soon. Bye bye. Take care.